a little bit on terminology. The slides we're getting ready to show talk about vibration on aircraft. And when we talk about that vibration, we're going to be talking about it in terms of inches per second. So that's the velocity of the vibration. So we measure it in acceleration, but because of the speeds that we're operating at, velocity actually works a lot better. And so we display all the data in inches per second, and that's the velocity that that airframe or that engine or that propeller is moving up and down. Something else we're going to talk about are the per ratios. So it's kind of important to kind of get through this little section on what the pers are. So a 1 per vibration means that that vibration occurs once per prop rotation. So if the propeller is spinning at 2400 RPM and the vibration occurs at 2400 RPM, then that's a 1 per vibration. And we know that that is caused by the propeller. A 2 per vibration is something that occurs twice per rotation. And so that would be, say, from a two-bladed propeller. Each blade, as it passes maybe a part of the cowling or a wing, in the case of the long easy, the two blades pass behind the two wings, and so you get 2 thumps per revolution. So something occurs twice per the rotation of the blade. So that'd be a 2 per vibration. You can also have a 3 per if somebody has a 3-bladed propeller. You could have a 3 per, which means there's something occurring 3 times per rotation. Now, I kind of skipped over the half per. It's actually one of the most interesting vibrations because it gives us an idea of engine health. It will specifically tell us how well that engine's running. So a half per vibration is something that occurs every other rotation. So for a 4-stroke engine, each cylinder will fire every other rotation. And because it fires every other, it's called a half per. And the half per vibration is significant enough that it's given its own position on our spectral chart. So if you look over in the right-hand corner of this display, you'll see the velocity mode inches per second. There's an H for half per. Anything that shows up in that dashed vertical line under the H is a vibration at half per, which means it happens every other prop rotation. You see the 1, a little bit above 0.2 inches per second. That 1 indicates that that's a propeller vibration. So that's actually a mass error in the prop. It hasn't been balanced yet. You'll see a 2. There's a 2. That's a 2 per. And that's because this is a long easy, and when you fly the long easy, the blade passes behind the wing, and you get a thump-thump. You get twice per revolution, you get a vibration. And then you also notice something out between 2 and 3. That's actually a 2.6 per. That's actually the alternator. The driven pulley on the alternator is actually out of balance, and you can pick up that vibration. So we're able to look at this spectral graph and completely understand what's causing all the vibrations in that engine. So how do we correct it? We install the equipment, usually as far forward on the engine as possible, right up by the propeller. This engine has a prop extension, so it's as close as we can get is to the starter ring. We then run the engine, and this is the Dynavibe Classic, so this is a straight prop balancer. It's going to give us the magnitude of the vibration and the location of the heavy spot. So we warm the engine up. We use our averaging signal to lock in the RPM and the amount of vibration. This one is 0.88 IPS at 258 degrees. The FAA limit is 1.20. So this 0.88 IPS is 90% of the way to the FAA limit. This is a pretty bad vibration. When you're sitting in the cockpit of this aircraft, you'll get your teeth will chatter a little. You put your head against the windscreen, you get a very significant buzz coming off the airframe. So we've got our 0.88 IPS. It gave us the location of the heavy spot. So what we do After we shut down, we rotate that propeller till it's in line with the phototach. So you'll see the small yellow phototach lined up with the tape. And then after we have it lined up, we simply measure from the accelerometer, which is mounted vertically at the top of the engine, and we go in the direction of rotation, whatever it said on the screen, 258 degrees in this case. So right at the very top is 0 degrees. We go in the direction of rotation, 258 degrees, and that is the heavy spot. So the system tells you where that assembly is heavy. You could remove weight there, but in most cases it's a lot easier to add weight. So we're going to add weight to the opposite side. We start with 50 grams per IPS. So in this case we're going to add at 78 degrees in order to make that correction. We're going to rerun. Normally it takes 2 or 3 runs to get that vibration down. So I think this was after 3 runs, a final reading of 0.06 IPS at 313 degrees. Normally we want to see that below 0.07 and then we'll stop. All of the Dynavibe equipment allows you to go as low as you want. A lot of times it takes some time if you really want to get it to 0. A lot of our Reno racers really want to get that vibration completely eliminated so that at high speed those vibrations are nulled out.